Let's take a look at carboxylic acids. These are going to be the next functional group we look at. They're probably one of the more important functional groups. There are lots and lots to it, but we're going to focus mainly on some physical and chemical properties and naming. Now, some of the other functional groups, just to refresh your memory, we've dealt with our alkanes, single bonds, alkenes, double bonds, alkynes, triple bonds, and alcohols. And alcohols have a hydroxyl group, OH. So carboxylic acids have a head and a tail. They're polar. If they're quite short, they are soluble in water. Miscible means they can be mixed in any ratio and still dissolve. Ones that are longer sometimes get called fatty acids because that's what fats are. Now, the basic structure is a carboxyl group. Car for carbon, oxyl, meaning this double bonded oxygen, and OH group. Now, they exist in equilibrium, as shown here, and notice the charge here. This is the polar head. It's hydrophilic, meaning it loves water, likes to interact with water. The carbon chain, or R group at the end, 1, 2, 10, 18, or longer, is the hydrophobic end. It doesn't dissolve in water. This is going to be the basis for soaps when we get to soaps. Okay, we're still going to use the same rules for naming them. Count the longest continuous chain, but this carboxyl group is the most important part, and this is always going to be carbon 1. Okay, so let's take a look at naming them, and then we'll come back and look at these links. Here we have a structure. Now remember, we're counting the longest continuous chain. This is always 1, so this will be 2, 3, 4, now 1. Well, it's still the continuous chain, so that's 6. 6 is hex. The ending for carboxylic acids is anoic acid, and so we have hexanoic acid. Oh, 1, 2, 3, 4, 5. Sorry, pentanoic acid. This methyl group, it's 1 carbon long, is on carbon 1, 2, 3, so it's going to be 3-methyl pentanoic acid. Here we have another example. Again, count this as 1, 2, 3, 4. Nope, I can go 1, 2, 3, 4, 5. Nope, 1, 2, 3, 4, 5, 6, 7. 7 is heptanoic acid. We have an ethyl group on carbon 2 and a methyl group on carbon 5. So we're looking at 2-methyl, 2-ethyl. Oops, I didn't even see that. Forget everything I just said. 2 carbons here, 2 carbons there. So we have a diethyl, and they're on carbons 2, 3, and 4. Oh, I got to learn how to count them. Let's take a look at this one. 1, 2, 3, 4, 5. Pentanoic. 1, 2, 3, and 3-methyl. We have 2 methyls, so it's going to be 3,3 dimethyl pentanoic acid. What's the structure of 3-methyl heptanoic acid going to look like? Well, anoic acid means we have a carbon, oxygen, oxygen, OH. We have 7 carbons, and on carbon 3, a methyl group. So if we take a look, carbon 1, 2, 3, there's our methyl group, 4, 5, 6, 7. And that gives us our 3-methyl heptanoic acid. I'll make a different video that shows these reactions. Thanks for listening, and click Turn In to get credit. Oh, I forgot. We're going to look at those links. So here's the Wikipedia link. Now it gives lots of information, gives you a picture. We're going to talk about how this is going to be delocalized, forms resonance structure. That's a little bit beyond the scope of this class, but if you take organic chemistry in college, you will talk about that all the time. That stabilizes this functional group here, and that makes this hydrogen more willing to leave. When this hydrogen is more willing to leave than stay, that's what makes this an acid, because it's donating hydrogen, donating a proton. Now there are lots and lots of common names, because quite often these chemicals were discovered before they knew what they were, and so they have a name for them. Here's a place where they come from. Caproic acid is from goat fat. That's the same basis as Capricorn, like the Tropic of Cancer, Tropic of Capricorn, and Capricorn astrology. Coconuts, vinegars are acetic, butter, butyric. You're going to miss that smell when we don't get to do those esters. And you can just see there's a wide variety of them. You can take a look at them. There's all kinds of different go beyond readings that you can look at. Let's also take a look at the Chem Guide. Now, if you are ever stuck on any chemistry topic at all, general chemistry, organic chemistry, any chemistry at all, this Chem Guide, although it's put out of the United Kingdom, and they talk about their end-of-year standardized tests, it's a great site for all sorts of things. And they're going to go through here and talk about these organic acids as weak acids, meaning they don't dissociate very much. There's that equilibrium we talked about, forming the hydronium. Remember hydronium from last year? And once you get beyond the basics here, this is stuff that, while you will do in a college class, we're not going to cover. Okay? But you can read it if you're interested or bored or super sure you're going to get into vet, dentistry, medicine, organic chemistry, nursing. They're all going to do organic chemistry. And they go through a ton of information, and it's a really good website. So I hope you learned some stuff, even though I screwed up a bunch. Talk to you later.